Hello, my name's Isaiah, and today we're going to go over the temperature portion of our 3D printing repair and diagnostics tool. So we'll go ahead and jump into the home page. Here you can see that there's a lot of information on your printers, from the status of the printer to what type of material you're utilizing to the actual file type. And you can even see camera information and the status of the printer as it's running. But what's really unique is our AI insights, which you can see here. We don't have a lot of time to dive into that, but you can see all of that in the settings. But we're going to see if we can solve what happened with this printer, which has failed and stopped, as we can see here. Now, it automatically detects that it failed, and it tells us to generate a report. We're just going to look at the temperature graph today and see what we can do. So it takes a while for these reports to generate, but once they generate, you have a full history of what happened to the printer as it was running. Now that the report has loaded, we can go ahead and try to figure out what happened. So you see that the failure was actually an auto stop, so we have the chance to save the print here. Now, you'll notice that we use layer lines instead of actual time, and this allows us to edit the G-code and save a printer if we have an auto stop incident like this. We have this weird cyclical temperature graph going on the hot end, and you can see our AI assistant has actually detected that we have temperature instability. This is a relatively new printer, but it's having a low success rate. So we want to see if we can't get more information and solve this problem. So we'll go ahead and drop in the 3D view. Now that this 3D temperature data is loaded, we're going to go ahead and start animating this and see if we can figure out what happened. So all of this is the historical data as the hot end moved, and it measures any temperature deviations from the optimal temperature for your hot end. So this is specifically for PLA, and we know that we're looking for about 215 degrees Celsius. Looking at the data, we can see that there's a cold region. And just looking at the 2D graph, we couldn't see this before, but it looks like it's only happening in one section of the part. And it turned out that it was the AC vent that was causing this part to fail. And so this caused warping, this caused layer line issues, and was the reason why all of these parts were failing. You can see that if you were producing this part, if you had this information, you could potentially save hundreds and thousands of dollars and avoid the headache of having failed parts on the bed. Now, I want to talk about how we work with almost every slicer and every 3D printer out there. So if you're interested in our product, we will integrate with your systems. I hope this was helpful, and if you're interested in more, go to headwind.com to sign up for a demo, and we'll show you more of our product. Thank you.